This is the first part for trigonometry, where we look at trig ratios. Okay. Firstly, we need to know some special angles. You don't really need to cram these because you have a calculator in your exams, but it's just faster to know these and where they come from. So suppose we had these two triangles right here. Okay. And just with these two triangles, we'll get three angles and their values for sine, cos, and tan of those three angles, right? Those three angles are going to be 30, 60, and 45. From this triangle, we get what it is for 45, because if you have 45 degrees, that means it's going to be an isosceles triangle. Obviously, given it's a right angle triangle, because that's where you use SOHCAHTOA. And if it's isosceles, because both of these are going to be 45, then we get that both of these sides are going to be a unit, right? Let's just assume it's a unit, because that's the easiest way of doing it. And here, if we use Pythagoras theorem to find the final part, we will get root of 2. Yeah, and you can do this to confirm. Now, you go and use SOHCAHTOA, which you did learn in IGCSE, but if you have forgotten, then you start off with sine, which is opposite over hypotenuse, cos, which is adjacent over hypotenuse, and tan, which is opposite over adjacent. And what these things are, opposite, adjacent, and hypotenuse, are just the sides on a right angle triangle. Where if you have a right angle triangle, then the opposite side to the right angle, which is 2 in this case and root 2 in this case, these are the hypotenuse, which is the h's. And then you have a certain angle that you have. So suppose if you have sine of 30, then that 30 is your angle, and you will identify it on your triangle. So it's this in this case, and what your opposite side would be is the side opposite to that angle. So in this case, if when your angle is 30, your opposite side is 1. When your angle is 60, your opposite side is going to be whatever side this is, which again we can find from Pythagoras theorem. We're going to get root 3 in this case. So the opposite for 60 is root 3. The opposite for 30 is 1. The opposite for 45 is 1, right? And the adjacent is that remaining angle that is there. So for 30, that adjacent is going to be root 3. For 60, that adjacent is going to be 1. For 45, the adjacent and opposite are the same. So the adjacent is going to be 1 again. So when you look at sine 30, we are looking at the opposite angle to that 30 and the hypotenuse of that 30, and you're going to divide them to each other. So take the 30, opposite is 1, and the hypotenuse is 2, so 1 over 2, and that's your value for sine 30. For cos 30, we are looking at the adjacent of 30, which is root 3, over the hypotenuse, which is 2 again, and that's going to be the value of cos 30. Then tan 30, which is opposite 1 over adjacent, right? So 1 over root 3, which is just root 3 over 3. Then you look at sine 60, the same thing, opposite over hypotenuse, so root 3 over 2. Cos 60 is adjacent over hypotenuse, so 1 over 2. And tan 60 is going to be opposite over adjacent, so root 3 over 1, which is just root 3. Then you go on to the second triangle, and sine 45 is just opposite over hypotenuse, so 1 over root 2, which is just root 2 over 2. Then cos 45, same thing, 1 over root 2, which is just root 2 over 2. And tan 45 is opposite over adjacent, so 1 over 1, which is just equal to 1. And with that, we get the values of sine 30, sine 45, sine 60, cos 30, cos 45, cos 60, tan 30, tan 45, and tan 60, which are all of these right here. And so if we look at a general triangle with theta and the height being y and the base being x and the hypotenuse being r, then we get these three identities right here. So sine of theta opposite over hypotenuse, cos of theta is adjacent over hypotenuse, and tan of theta is going to be opposite over adjacent. we can use these to identify what type of triangle we are looking at. So suppose we have one of the information, which is cos theta is root 5 over 3. With that directly, you can get that the triangle that they are talking about is this triangle right here, where this is theta and adjacent is root 5 and the hypotenuse is 3. So hypotenuse is 3, adjacent is root 5. With that, we can get the opposite side as well, which is a squared plus b squared equals to c squared. And with that, we're going to get the opposite side being 2. So with just this triangle right here, we can get the sine theta and the tan theta as well. Okay, so sine theta being opposite over hypotenuse, so 2 over 3. Tan theta being opposite over adjacent, which is 2 over root 5. And cos square theta being just cos theta squared. So root 5 over 3 squared, which is just 5 over 9. Then we want to show that 1 minus tan square theta over cos theta plus sine theta equals to this thing right here. So we can do that. 1 minus tan square theta, so 2 over root 5 squared, which is just 4 over 5, over cos theta, which is root 5 over 3, plus sine theta, which is 2 over 3. And here what we can do is make them into one fraction for both. So what we get on top is 1 over 5 divided by root 5 plus 2 over 3. And this is just 1 over 5 divided by root 5 plus 2 over 3, which is just 1 over 5 times 3 over root 5 plus 2. And that gives us 3 over 5 root 5 plus 2. Then what we would do here is we want to rationalize the denominator. We did this in IGCSE. We can multiply by the conjugate of root 5 plus 2. So I'm going to take this up here. 3 over 5 root 5 plus 2 multiplied by root 5 minus 2 over root 5 minus 2. And this is going to give us 3 root 5 minus 6, which is what we wanted in the numerator, over root 5 plus 2 times root 5 minus 2 is just going to be 5 minus 4. So 5 minus 4, because root 5 times 5 is going to be 5. And 2 times negative 2 is negative 4. Obviously, this is difference of 2 squares, so we don't have the middle term. And this just gives us 5 times 1, which just gives us 5. So we end up getting 5 in the denominator, which is what we wanted as well. So we showed that 1 minus tan square over cos theta plus sine theta equals to this thing right here. Next, find the exact value of sine 30 times cos 45, sine square of pi over 3, and 2 cos pi over 4 sine pi over 6 over cos square pi over 3 plus sine square pi over 3. Now remember, we did the whole radians conversion thing from circular measure. And yeah, that's all that is there to this. So we know the value of sine 30, which is equal to the value of sine pi over 6, which is just 1 over 2. Then we know cos 45, which is cos of pi over 4, which is 1 over root 2 or root 2 over 2. Then we know the value of sine 60, which is sine pi over 3, which is root 3 over 2. Then we only need cos pi over 3 next. So cos of 60, which is cos of pi over 3, which is going to be 1 over 2. And since we have the value of all of these, we can just plug in into each of these to get the exact value. So sine 30 times cos 45 is just 1 over 2 times root 2 over 2, which is just root 2 over 4. Then sine square pi over 3, which is just root 3 over 2 squared, which is just 3 over 4. And then 2 times cos pi over 4 sine pi over 6, which is 2 times root 2 over 2 times sine pi over 6, which is 1 over 2, over cos square pi over 3, which is 1 over 2 squared, plus sine squared pi over 3, which is root 3 over 2 squared. And 1 over 2 squared is 1 over 4. Root 3 over 2 squared is 3 over 4, which just gives us 1 in the denominator. So the answer is going to be root 2 over 2 divided by 1, which is just root 2 over 2. And that's going to be the answer for C. Next, this is a general definition of an angle, where the angle is a rotation of the line segment about the fixed point O. Okay? And that angle is always measured from the positive x direction, meaning we go anti-clockwise, right? From the x-axis, we go upwards, anti-clockwise. Clockwise, if you go clockwise, then it's a negative angle. And that Cartesian plane, the xy plane that we have, is divided into 4 quadrants. I'm sure you've done this in IGCSE as well, where I remember you had done all students take chemistry. And we'll go into this further on along the class, but you just remember these 4 quadrants, right? And the angle theta is in the quadrant where that line segment that we talked about is. When you're looking at the reference angle, which is the original theta that we are looking at, that is the acute angle that is made with the x-axis. So wherever that is, it's the acute angle, meaning the smallest angle that is made with the x-axis. Remember, acute angle is the angle between 0 and 90 degrees, which will give you the smallest angle made by the x-axis. Meaning, if it's in the second quadrant, then the acute angle is this right here. And we're going to have it as a negative angle because we're going clockwise. If it's right here in the fourth quadrant, again, negative angle because it's going clockwise. If it's in the third quadrant or first quadrant, again, the angle is going to be this right here, the acute angle, which is going to be a positive angle in this case because it's anti-clockwise. And if it's in the third quadrant, again, the acute angle is going to be this right here, and it's going to be a positive angle because it is going anti-clockwise. So these are all the reference angles, the theta. Why this is important, I will come to that. Now, for each of the following angles, draw a diagram showing the quadrant in which the rotating line OP lies, and then find the acute angle that the line OP makes with the x-axis. So let's start off with 120 degrees. So remember, we have the xy plane for each of them. Let's just draw this really quickly. And the first one, 120 degrees, remember, we always start from here. 120 degrees is just going to be 90 plus 30 degrees, right? That's going to be the line. Then the 60 degrees that's there remaining, which is going to be down here, that's going to be the acute angle because that's the smallest angle that you make with the x-axis. And obviously it's going to be negative 60 degrees because we are looking at a clockwise angle. The next one, 430 degrees, which is just 90, 90, 90, 90. We get 360. Then we want 70 degrees more, right? And we end up getting something like this. And the acute angle is going to be that 70 degrees, and it's going to be positive because it's anti-clockwise. 3 pi over 4. Now we're going to the radian side, and obviously you know that each of these quadrants is pi over 2, which is 90 degrees. So 3 pi over 4 is pi over 2, then quarter pi extra. So we're looking at this right here. And that's the line that it makes. And remember, this acute angle is going to be the angle right here, going this way. And the size of it is going to be pi over 4. And because it's clockwise, and the acute angle in this case is going to be, because it's clockwise, negative pi over 4 radians. Lastly, negative 2 pi over 3 means we're going clockwise from the start as well, right? So negative 2 pi over 3 means we're going negative pi over 2, and we're going an extra pi over 6. So this is it right here, where the acute angle is going to be this thing here, and the size of this is going to be pi over 3. And is it going to be positive or negative? positive, and the reason for that is that it is anti-clockwise. So the acute / reference angle is going to be pi over 3 radians. Okay, so we saw these 4 angles, and we also found how to find the reference angle for each. Now, in general, the trigonometric ratios of any angle theta in any quadrant is defined by this thing right here, as we saw previously. And that theta is always the reference angle that we are looking at. Now, if you looked at the reference angle for in all the 4 quadrants, there are the times when you have the same reference angle in either of the quadrants, right? And those angles that are the same, obviously this angle right here is going to be the same. And so that answer you get from applying the trigonometric function, which is either sine, cos or tan to that theta, is always going to give you the same magnitude, so the same value of the trigonometric ratio. Because in a part of trigonometric ratio, we have the sign, which is either positive or negative, which we're going to look at here, and we have the magnitude, which is the size of that fraction, right? And if the angle is 30 degrees, whether it's positive or negative, the size is always going to be the same, given that it is always a sine, always a cos, or always a tan. What I mean by this is sine 30 is 1 over 2, as we've seen previously. Sine negative 30 is going to be negative 1 over 2. Okay? Cos 30 is root 3 over 2, as we saw. And so cos of negative 30 is also going to be root 3 over 2. The magnitude side I'm talking about, right? So the value of it is still going to be root 3 over 2. The sign maybe will change or maybe won't change, depending on what the trigonometric function we are putting into it is. But the magnitude will remain the same, which is what this whole section is about. Meaning, if we have these 4 angles, and suppose all of them are theta, meaning the same angle theta, the acute angles I'm talking about, the reference angles, that just means that sine theta of all of this will have a certain magnitude. So if sine theta here is either positive or negative 3 over 4, then sine theta here is also going to be positive or negative 3 over 4, also going to be positive or negative 3 over 4, also going to be positive or negative 3 over 4. And the magnitude stays the same. Same with cos theta, same with tan theta. The magnitude of that ratio stays the same. What changes is just the sign, given that you're using the same trigonometric function, so either sine, cos or tan, and that's constant throughout the 4 quadrants that you're looking at, and that you're using the same reference angle, meaning your theta is the same in all. Now, remember I said we coming back to the ASTC, all students take chemistry, and here we find that in the A quadrant, which is the all quadrant, all sine, cos and tan are all positive right here. In the second quadrant, which is the S quadrant, only sine is positive, but cos and tan are negative. In the tan quadrant, only tan is positive, whereas sine and cos are negative. And then in the cos quadrant, which is the fourth quadrant, only cos is positive, which means sine and tan are negative. And so just with this, just with the value of your theta and the quadrant that it's in, we can get the entire value of that ratio. Obviously, the quadrant telling us the sign of that trigonometric ratio, and the theta giving us the magnitude of that trigonometric ratio. Next, express in terms of trigonometric ratios of acute angles. So sine 140, remember you are taking 140 degrees. And so you have 40 degrees that's left. And so the magnitude of that sine 140 is obviously going to be in terms of the reference angle, as I just said. The reference angle in this case is 40 degrees. And so sine 140 the magnitude, right, is going to be the same magnitude as sine of 40. Now what's left is the sine of that sine, meaning the positive or negative of that trigonometric ratio. And because it's in the second quadrant, which has the sign as positive, we're going to have this as positive. That means sine 140 is the same as positive sine of 40. When you look at cos of negative 30, we are going downwards firstly. So 90 degrees and 40 degrees, which leaves us with the acute angle of 50 degrees right here. This means that the magnitude of this cos negative 130 is the same as the magnitude of cos 50. So cos negative 130 is the same as the magnitude of cos 50. And then the sign, meaning the positive or negative, because it's in the third quadrant has only tan as a positive. That means cos is going to be a negative in that quadrant. That means the total value of cos of negative 130 is negative cos of 50. Negative because of it's in the third quadrant, and cos of 50 because the reference angle is 50. Next, given that cos theta equals to 3/5 and that the angle is between these, find the value of sine theta and the value of tan theta. So we draw our xy plane and the angle is between this, so between 180 and 270, which is in the third quadrant. That means sine is going to be negative and tan is going to be positive straight away. And then what we can do is use the triangle fact. So if we have theta here, then adjacent over hypotenuse, so adjacent is 3, hypotenuse is 5, and if we do Pythagoras theorem, we'll get that the opposite is 4. And remember, sine theta is opposite over hypotenuse. So sine theta, the magnitude of it is going to be 4/5. Tan theta, the magnitude of it is going to be opposite over adjacent, which is 4/3. And since tan theta is positive, sine theta is negative, we get that this is going to become negative 4/5, while this is going to remain 4/3 positive. Next, without using a calculator, find the exact values of sine 120 and cos 7π/6. Now, sine 120 degrees means the reference angle is 60 degrees, and the way we get that is 120 is here, and the remaining will be 60 degrees right here. And so the reference is 60 degrees. That means sine 120 the magnitude of it will be equal to sine of 60. And obviously it's going to be positive because it's in the second quadrant where sine is generally positive. And so the value of sine 120 is just value of positive sine of 60. And we know what the sine of positive sine of 60 is, which is root 3/2, which we got from the first slide that we did today. So sine 120 is just root 3/2. When you look at cos 7π/6, we are looking at pi, then π/6 right here. Right? Obviously, this whole thing is pi because 180 degrees, this thing right here. And so what's remaining here is π/6. Therefore, the magnitude of cos 7π/6 is the same as the magnitude of cos π/6. Okay? The only thing is going to be that is going to be negative because the fact that it's in the third quadrant where only tan is positive, and so cos is going to be negative in that quadrant. So cos 7π/6 is just equal to negative cos of π/6. Now the value, the magnitude of cos π/6 is just cos of 30 degrees, and cos of 30 as we know is root 3/2 as well. So equals to negative root 3/2. Root 3/2 we get from the fact that the reference angle is π/6, and the sign being negative we get from the fact that it's in the third quadrant. Finally, given that sine 50 is equal to b, express each of the following in terms of b. So firstly, we can draw our triangle where we get theta and opposite over hypotenuse. Opposite in this case is b, and hypotenuse in this case is 1, because b is just the same as b/1. Obviously, theta in this case is 50 degrees. Then our last side is going to be the square root of 1 minus b squared. And with that, we get our triangle, right? So from this, we can get the value of cos 50 and the value of tan 50 as well. So cos 50 is equal to adjacent over hypotenuse, which is just square root of 1 minus b squared. And tan of 50 is going to be opposite over adjacent, which is b over root of 1 minus b squared. Now we have this as a start. We can do the following. So sine 230, we can draw our quadrant. So 230 degrees is 180 degrees plus 50 degrees more, which leaves us with 50 degrees as our reference angle. And since it's in the third quadrant, it's going to be negative of that. So sine of 230 is going to be negative sine of 50. Sine of 50 because the reference angle is 50, and the negative sign because it's in the third quadrant, which has the sign as negative. And so sine of 230 is going to be equal to negative sine of 50, which is b. Cos of 50 we just found here, which is root of 1 minus b squared. And sine of 230 is negative b. Then tan of 40, we can actually use this exact same triangle. Because remember, if one of the angles is 50, and then we have a right angle, that means the other angle is going to be 40 degrees. And tan of 40 is going to be opposite over adjacent in terms of that 40 degrees. So opposite over adjacent. So it's going to be root 1 minus b squared. Root 1 minus b squared over b. That's going to be the value of tan 40. Then tan 140, remember if you look at our quadrants, 140 degrees is just right here with the reference angle being 40 degrees. But because it's in the second quadrant, the value of tan is going to be negative. Which means that tan 140 is going to be equal to negative tan of 40. Which means it's going to be equal to negative root 1 minus b squared over b. Yeah, because the negative version of this right here. And that is it for this lesson.